Question 22, Math 1, release items, calculator active. A club began with 3 members. Each month, each member brought one new member. Which function can be used to determine the number of members X months after the club began? See if you can figure this question out. Pause and try the question before you move on and check my answer. And then make sure you use the calculator if you need to. And we're going to go over this in 3, 2, 1. You may find it helpful to make a table of values for this question. That way you can check some answers using a graph if you need to. So first thing is we got to visualize what's going on. Each month, each member brought one new member. So if you think about if we started with 3 members, so at 0 months, your starting is always going to be 0. We have 3 members. Well, after 1 month, if each of those bought 3 members, so if we got 3 things, or each bought 1 member, excuse me, now there's going to be 2 for each person. So now we have 6 members total. And after 2 months, if each of those brought 2 members, well, that's going to be 12, right? So you can see the pattern, and it's going to increase real quickly. That's going to be 12. Now that pattern, if you haven't figured it out, is just multiplying by 2, multiplying by 2. So if each month each person bought 2 members, you'd be multiplying by 3 because you got to include yourself, right? So that pattern's going to be, the next one after 3 months, it's going to be 12 times 2. That's going to be 24. And you can kind of see it's going to grow real quick. This is an exponential growth. Exponential is anytime you're multiplying the previous amount by a number. Linear would be adding a number to each previous amount. So this is going to be exponential. Exponential growth models are going to be characterized by having a starting value, which is going to be the number first. So you're going to see it in this format, y equals a, that's your starting value, multiplied by some base. That's going to be what you're multiplying by, your constant multiple. So this is going to be your initial or starting. This is going to be your multiple, constant multiple. Sometimes it's called the multiplying constant, the base, whatever you want to call it, but it's what you're multiplying by, okay? And then the variable is in the exponent. So when you plug in like 3 or 4, you can actually figure out what the number is. Well, what is our starting value? It's going to be 3. So this is going to be 3. What are we multiplying by? 2. And so you can see the answer is going to be D. And we didn't really need the calculator with this, but I'm gonna model with the calculator what you're looking for on here. So say you didn't remember what the format of the function looks like, but you knew that you could make a table basically doing 0, 1, 2, 3, and 3, 6, 12, 24, and kind of figuring out the numbers. So if you add a table here, we can key those X and Y values in real quick. It might help if you actually put the right number in. And you can zoom out and kind of see what those points look like. And then if you needed to, you could go through your answer choices and you could figure out which one of these is going to give you the function that goes through those points. If you know how to get the X and Y values and you know how to key in a data in a table, you can kind of go through and say, let's look at 2x plus 3. That doesn't hit those points, so we'll hide that one. 3x plus 1, same deal. This does have the appropriate curve to it. It's got that exponential growth model, but it's not going through those points. So we can see it's going to be this one right here, 3 times 2 to the x power. And so that's a graphical way to do it. Thanks for watching.